Now we will look into some MCQs of the chapter Mathematical Logic. This is the question: equivalent circuit for the logical expression negation of P and Q, or negation of P and negation Q, or P and negation Q is the options is given in the form of the circuits. This can be interpreted as if the points lie on the same line, the same circuit line, then this is AND. If they are in parallel connection, if they are in series, the expression is AND. If they are in parallel, the expression is OR. If the circuit is open, then it is negation, and in this case the open circuit is called the open circuit is normal P or Q. So basically what it means is, if the circuit is in series, then the expression is AND, and if it is in parallel, the circuit is OR. So first we'll simplify this equation in terms of just single P and single Q. So by distributive property, this can be simplified as negation P and Q, or here negation Q is common. So by distributive property we can write negation of P or negation of P or P and negation of Q. But negation of P and P, negation of P or P is truth. So this is negation of P and Q, or T and negation Q. Now T and negation Q is negation Q. So this is negation Q, negation P and Q. Or again using distributive property, this can be written as negation P or negation Q and negation P or negation P this is PQ or negation Q. So Q or negation Q is T. So this is negation P or negation Q, which is the same as negation of P or negation of Q. So the circuit equivalent of this is this one. So in this case negation P is open circuit, so this is in parallel, which is OR statement, and this is negation P and this is negation Q. So the equivalent circuit is this one, which is option D. The next question is, which of the following statement is false by taking their truth values? So these are the options. In this option, if and only if logic is used mostly. So first we'll draw the table for if and only if, that is biconditional statement. So let this be P, statement 1. Let the second statement be Q. So this is biconditional statement for P and Q. So the truth table is T, T, F, F, T, F, T, F. So for biconditional statement, if both the values are same, then the final logic is true, else it is false. So we'll check we'll use this table to check our answers. So 1 plus 7 is 8. This statement is true. So this is true, and only if and only if 3 plus 2 is 5. Now 3 plus 2 is 5 is also true. So this is T, biconditional statement, and T. So the logic is T. So this is true. This statement is true. 1 plus 7 is 8, which is true. And if and only if 3 plus 2 is 4. Now this statement is false. So this is false. Now T and F is F. So the answer for this is F. So this is false. So this is one of our answers. Let's see other one. 1 plus 7 is 10, which is false and biconditional statement if and only if 3 plus 2 is 4. Now this is also false. Now both the logics are same, so the final is false. True, since both have the same values. So the only statement which is false is B. So the answer is 1 plus 7 equals 8 if and only if 3 plus 2 is 4 is the false statement. Now we'll look into the questions of chapter trigonometric functions. The question is the number of values of x in the interval 0 to 3 pi, that is 0 to 2 pi 3 pi radians for angle x, satisfying the equation 2 sin square x plus 5 sin x minus 3 equals 0 is, these are the options. So first we'll simplify the equation. 2 sin square x plus 5 sin x minus 3 equals 0. So finding the roots of this quadratic equation, we get sin x is equal to 1 by 2 or minus 3. Now sin x value, the range sin x value lies between minus 1 to 1. So it cannot be minus 1 to 1. So it cannot be greater than 1 or less than minus 1. So this option gets cancelled. Sin x cannot be minus 3. So sin x is half. So when sin x is half, this we can say this is equal to sin x is equal to sin pi x. So this is a standard value for pi. We have to find the general number of general values of x such that it is greater than 0 and less than 3 pi. So general expression for x is x equals n pi plus minus 1 raised to n into pi by 6. Since this is the starting value of sin x, that is pi by 6. So now we put n equals 0, 1, 2, 3 and so on. So we get the values as theta equals theta, that is x equals pi by 6, 5 pi by 6, 13 pi by 6, 17 pi by 6. Once this exceeds the value, this becomes greater than pi by 3 pi. So this can be converted into degrees. So theta in degrees is 30, 150, 390 and 510. So there are only 4 values which are less than 3 pi and greater than 0 which satisfies this equation. So the answer is A, 4. So there are 4 values of x. The next question is, if sin square theta minus 2 cos theta plus 1 by 4 is 0, then the value of theta between 0 and pi are, these are the options. So first we will find the roots of this equation. So the equation is sin square theta minus 2 cos theta plus 1 by 4 equals 0. By using the formula b square minus x equals plus minus b plus or minus root of b square minus 4ac by 2a. By using this formula, we get now first this can be written as 1 minus cos square theta. So we got a quadratic equation in terms of cos theta. So we get the roots as cos theta is equal to 1 by 2 comma minus 5 by 2. Now cos theta lies between minus 1 and 1. So this is less than 1. So this is invalid. So the only value is half. So cos theta is half. Therefore cos theta is half, which is equal to cos pi by 3. So one value we got is pi by 3. So answer is D, pi by 3. So there is another value 5 pi by 3. So if we want to verify this, we can simply write this as 2 pi minus pi by 3. This is the same as cos theta is the same as cos of 2 pi minus theta. So cos pi by 3 can be written as 2 pi minus pi by 3, which is equal to cos of 5 pi by 3. So D is our answer, pi by 3 comma 5 pi by 3. Next question is, in a triangle ABC, if a square, b square, c square are in AP, Then cot A, cot B, cot C are in the options are GP, HP, AP or none of these. So the ABC are the sides of the triangle ABC. We have to find the relation between cot A, cot B and cot C. So we need cot A, cot B and cot C. Now cot is cos upon sine, and we know that cosine rule makes use of square of sides. So first we'll try to use cosine rule, and try to find a relation between the cots of the angles. So first we know that a square, b square, c square are in AP. So by definition of AP, arithmetic progression, b square minus a square is the same as c square minus b square. So this can be written as b square is equal to a square plus c square minus b square. So now we are somewhat getting this in terms of cosine rule. So dividing throughout by 2ac, we get b square by 2ac is equal to a square plus c square minus b square by 2ac. So this is the formula for cosine rule of angle B. So this is cos B, and this is, now by using sine rule. So since we got one cos, we need one sine. We need one sine. So now we bring this term in terms of sine of angles. So we know that sine A by A equals sine B by B equals sine C by C, which is equal to K. So therefore we can say A equals K sine A, B equals K sine B, and C equals K sine C. So we substitute this here. So B square is K square sine square B. So we got sine B and cos B. So we got cot B indirectly, divided by 2 into K sine A into K sine C. K gets cancelled. We are left with sine square B by 2 sine A sine C equals cos B. Bringing one sine B here, we get sine B by 2 sine A sine C. Now B is A plus C by property of a triangle. So this is pi minus A minus C, since sum of all three angles is 180 degree. So we can sine pi minus theta is the same as sine pi theta, sine theta. Sine pi minus theta is sine theta. So this can be written as sine of pi minus A minus C, which is the same as sine of A plus C. So this is sine of A plus C. This is equal to cos B upon sine B is cot B. So now we expand this by using sine A plus B A plus C formula. So this is sine A cos C plus cos A sine C divided by sine A sine C. This is equal to cot B. So simplifying this, we finally get sine A cos C upon sine C plus cos A upon sine A is equal to cot B. That is cot C plus cot A is equal to, this is times 2 by 2 is equal to cot B. That is cot C plus cot A is equal to 2 times cot B. So we can see this expression is for arithmetic progression. Sum of two numbers is equal to 2 times the mean number, that is cot C plus cot A equals 2 cot B. So the values cot A, cot B and cot C are in AP. So the answer is B, AP.
Next question, the solution of tan inverse x plus 1 upon x minus 1 plus tan inverse x minus 1 upon x is equal to tan inverse of minus 7 is. We're given 4 options over here. We can write this expression as x plus 1 upon x minus 1 plus x minus 1 upon x, which is 1 minus x plus 1 upon x minus 1 upon x is equal to minus 7. Further solving this, we get x square minus 4x plus 4 equal to 0, where we can write this as x minus 2 the whole square, where we get x is equal to 2. Putting x is equal to 2 in a given solution, or sorry, that is given equation, we get tan inverse of 3 plus tan inverse of half equal to tan inverse of minus 7. Here xy is equal to 3 into 1 by 2, which is equal to 3 by 2, which is greater than 1. If x is greater than 0, y is greater than 0, and x into y is greater than 1, then tan inverse x plus tan inverse y, which is equal to pi plus tan inverse x plus y upon 1 minus x into y. Here x is equal to 2 is a contradicting to this result, hence the given equation has no solution. Therefore option D is the correct answer. If sin inverse x plus sin inverse y plus sin inverse z is equal to 3 pi upon 2, then the value of x raised to 100 plus y raised to 100 plus z raised to 100 minus 9 upon x raised to 101 plus y raised to 101 plus z raised to 101 is. We give 4 options over here. Since mod of sin inverse x is less than equal to pi by 2, so we have sin inverse x plus sin inverse y plus sin inverse z is equal to 3 pi by 2, where we can write this as sin inverse of x is equal to sin inverse of y is equal to sin inverse of z is equal to pi by 2, where we get x is equal to y equal to z equal to sin pi, which is equal to 1. So now x raised to 100 plus y raised to 100 plus z raised to 100 minus of 9 upon x raised to 101 plus y raised to 101 plus z raised to 101 will be equal to, substituting the value of x, we get 1 plus 1 plus 1 minus of 9 upon 1 plus 1 plus 1, which is equal to 3 minus 3, which is equal to 0, which is our option A. Therefore option A is a correct answer. If A vector, B vector and C vector are non-zero vectors such that A, B and C is equal to A vector, that is mod of B vector, C vector, then A vector plus B vector and C vector the whole square is equal to 0. We give 4 options over here. We have A vector, B vector and C vector is equal to mod of A vector into mod of B vector into mod of C vector. If A vector, B vector, C vector are mutually perpendicular vectors, then we can write this as A vector plus B vector plus C vector mod the whole square, which is equal to, because all this we can write this as A vector the whole square plus B vector the whole square plus mod of C vector the whole square, plus this can be written as 2 into A into B vector plus B vector into C plus C into A, which is, we see this is equal to 0, that is A vector the whole square plus B vector the whole square plus C vector the whole square equal plus 2 into 0, which is we get as answer A vector the whole square plus B vector the whole square plus c vector the whole square. Therefore, we see our answer matches with option C. Therefore, option C is the correct answer. The incenter of a triangle whose vertices are P 0, 2, 1, Q minus 2, 0, 0 and R minus 2, 0, 2 is the incenter of a triangle whose vertices are P 0, 2, 1 and Q minus 2, 0, 0 and R minus 2, 0, 2 is. We're giving four options over here. Since given vertices, we have x is equal to qr. We solve for qr, we get 0 plus 0 plus of 4 equal to 2. And for y, we can write as pr is equal to under root 4 plus 1, which is equal to root 9, which is equal to 3. And for z, we can write as pq, which is under root of 4 plus 1, which is equal to 3. Let h, that is h vector, be the incenter of triangle ABC. So h vector we get as x into p vector plus y into q vector plus z into r vector, which is x plus y plus z, where we can write this as 2 into 2j plus k plus 3 minus 2i plus of 3 minus 2i plus 2k upon 2 plus 3 plus of 3. Therefore, h vector is equal to minus 12i plus 4j plus 8k upon 8, which is equal to, we can write that as minus 3 by 2 I plus of j plus of k. Therefore, in center we get as minus 3 by 2 half 1, which is, we see our answer matches with option B. Therefore, option B is a correct answer. The shortest distance between the lines as given below here. Rewrite the shortest distance between the lines are given over here. We give four options. We rewrite the given lines as a vector I minus 2j plus 3k plus of t minus I plus of j minus of 2k, and r is equal to I minus j minus k plus of s I plus 2j minus 2k. Comparing both, we get r is equal to a1 plus p1, r is equal to a2 plus s of p2. We compare with ra1 plus tb1 and ra2 plus of sb2. We get a1, which is equal to I minus 2j plus of 3k. P1 is equal to minus I plus of j minus 2k. A2 is equal to I minus j minus k. B2 is equal to I plus of 2j minus of 2k. Where we get A2 is equal, we solve A2 minus of A1, we get j minus 4k. And we see for P1 into B2, which is equal to I, j and k, that is minus 1, 1 and minus 2, 1, 2 and minus 2, which equal to, we get 2i minus 4j minus of 3k. Now we can use short distance formula, that is short distance is equal to a2 bar minus of a1 into b1 into b2. mod of upon P1 into P2. Substituting the value, we get 8 upon under root 29 units, which is our answer matches with option B. Therefore, option B is a correct answer. The image of the point 1, 6, 3 in the line x by 1 is equal to y minus 1 by 2 and z minus 2 by 3 is, we give 4 options over here. Let p dash be x2, y2, z2 be the image of p1, 6, 3 in the given line. The general point of the given line is m r, 2r plus 1, 3r plus of 2. So the direction relation of line PM r minus 1, 2r minus 5, 3r minus 1. Since the line is perpendicular to a given line, we can make a diagram that is point P1, 6, 3 perpendicular to the point of P dash x2, y2 and z2. And point at this at M. Since the line PM is perpendicular to the given line, therefore we can write this as 1 minus r1 minus 1 plus 2, 2r minus 5 plus of 3, 3r minus 1, which is equal to 0, which we get r is equal to 1. Therefore, m is equivalent to 1, 3, 5. Since m is a midpoint of p into p dash, therefore 1 is equal to 1 plus x2 upon 2, 3 is equal to 6y plus 2 upon 2, 5 is equal to 3 plus z2 upon 2. Therefore, we get x2 is equal to 1, y2 is equal to 0, z2 is equal to 7. Therefore, image of p is equivalent to 1, 0, 7, which is our answer matches with option B. Therefore, option B is a correct answer. The equation of plane passing through line of intersection of the planes is given, and it is passing through 2, 2, 1 is, we give 4 options over here. The given planes are 3x minus y plus 2z is equal to 4 and x plus y plus z is equal to 2. The equation of any plane through line of intersection of given plane is 3x minus y plus 2z minus 4 plus k x plus y plus z minus 2 equal to 0. If it passes through point 2, 2, 1, then it will be 6 minus 2 plus 2 minus 4, that we substitute the values, plus k 2 plus 2 plus 1 minus 2, which is equal to 0. Therefore, 2 plus 3k is equal to 0, where we get k is equal to minus 2 upon 3. Therefore, let this be kept as 1. So from 1 we get 3x minus y plus of 2z minus 4 minus 2 by 3 x plus y plus z minus 2 equal to 0, which we solve further, we get 7x minus 5y plus 4z is equal to 8. Therefore, we see our answer matches with option A. Therefore, option A is a correct answer. The equation of a plane passing through the line of intersection of the planes are given over here. So they are and parallel to the line r bar, that is r vector given over here. Yes, we given 4 options over here. So the given planes are 2x minus y plus z equal to 3 and 4x minus 3y plus 5z plus 9 equal to 0. Equation of any plane through line of intersection of given plane is 2x minus y plus z minus 3 plus k, 4x minus 3y plus 5z plus 9 equal to 0. Let this be equation 1. 2 plus 4k x plus minus 1 minus 3k y plus 1 plus 5k z plus of minus 3 plus 9k equal to 0. So the direction ratio of a normal to the plane are 2 plus 4k comma minus 1 minus 3k 1 plus 5k. So direction ratio of a given line are 2 comma 4 comma 5. Since normal is perpendicular to the given line, therefore 2 into 2 plus 4k plus 4 into minus 1 minus 3k plus 5 into 1 plus 5k equal to 0, which is we solve further, we get k is equal to minus 5 by 21. So from 1 we get 2x minus y plus z minus 3 minus 5 by 21, 4x minus 3y plus 5z plus 9 is equal to 0. For this one we get 11x minus 3y minus 2z equal to 54, which is we see our answer matches with option B. Therefore option B is our correct answer. If log x plus y is equal to 2xy, then y, differentiate of y, that is y differentiate 0 is equal to, we are given 4 options over here. We differentiate both the side, we get 1 by xy, 1 upon x plus y, 1 plus dy by dx, which is equal to 2x dy by dx plus of y. Now rearranging, we get 1 plus x plus y minus 2y is equal to 2x minus 1 upon x plus y dy dx. So we rearrange, we solve this, we get 1 minus 2xy minus 2y square upon x plus y equal to 2x square plus 2xy minus 1 upon x plus y dy by dx. Solving this further, we find the value of dy by dx, that is we get dy by dx is equal to 1 minus 2xy minus 2y square upon 2x square plus 2xy minus 1. So if x is equal to 0, then the log of x plus y is equal to 2xy. If we substitute, we get 0 plus of y, which is equal to 0. Therefore y we get as 1. Therefore dy by dx 0 comma 1 is equal to, we substitute the value of x and y, that is 0 comma 1, we get 1 minus 0 minus 2 upon 0 plus 0 minus 1, which is equal to minus 1 upon minus 1 is equal to 1, which is we see our answer matches with option A. Therefore option A is the correct answer. If y is equal to sine of sine x and d square y upon dx square plus dy dx tan x plus fx is equal to 0, then fx is, we have y is equal to sine into sine x, sine of sine x. Therefore we differentiate, we get dy by dx is equal to cos of sine x cos x. Differentiating again, we get d square by dx square equal to minus cos sin x plus cos x sin x cos x, which is equal to minus cos sin x minus of cos square x into sin of sin x. So we have d square y upon dx square plus of dy by dx tan x. Therefore we substitute the value of dy by dx and d square y upon dx square. We get minus cos sin x into sin x minus cos square x sin x plus cos sin x into cos x into tan x. which is equal to minus cos square x into sin x. Further, we shift minus cos square x into sin x on the left hand side. So we get d square y upon dx square plus tan x dy by dx plus of cos square x sin into sin x, which is equal to 0. Therefore, we get f of x is equal to cos square x into sin x, where we compare this with the given equation. Therefore, we get f of x is equal to cos square x into sin of sin x, which is, we see our answer matches with option D. Therefore, option D is the correct answer. Let f of x is equal to 1 plus mod of sin x raised to a upon mod of sin x when x is greater than minus pi by 6 and less than 0. For b, when x is equal to 0. For e raised to tan 2x upon tan 3x when x is greater than 0 and less than pi by 6. Then the value of a and b if f is continuous and x is equal to 0 are respectively. We give 4 options over here. So limit x tends to 0 from the left hand side of fx is equal to limit x tends to 0 1 plus 1 upon mod of sin x raised to 1 upon mod of sin x, which is raised to a, which we get equal to e raised to a. Similarly, for limit x tends to the left hand side of f of x is equal to limit x tends to 0 e raised to tan 2x upon tan 3x, which is equal to, we get e raised to limit of x tends to 0 for tan 2x upon 2x into 2x upon tan 3x upon 3x into 3x, which is equal to, we get e raised to 2 by 3. Therefore, limit x tends to 0 from the left hand side of f of x is equal to f of 0 is equal to limit x tends to 0 from the left hand side of f of x. Therefore, e raised to a b equal to e raised to 2 by 3, which we get a is equal to 2 by 3 and b is equal to e raised to 2 by 3. Therefore, we see our answer matches with option B. Therefore, option B is the correct answer. The values of a and b so that the function of f of x defined by f of x is equal to x plus a root 2 sin x if x is greater than equal to 0 and less than pi by 4, 2x cot x plus b if x is greater than equal to pi by 4 less than equal to pi by 2, a cos 2x minus b sin x if x greater than equal to pi by 2 less than equal to pi becomes continuous. We're given 4 options over here. Limit x tends to pi by 4 from the left hand side of f of x is equal to limit x tends to pi by 4 from the right hand side of f of x. Then we substitute the values, the expressions. We get limit x tends to pi by 4 from the left hand side x plus a root 2 sin x equal to limit x tends to pi by 4 from the right hand side 2x cot x plus b. Further, we get pi by 4 plus a equal to pi by 2 plus of b, which is a minus b equal to pi by 4, which is equation 1. So we see limit x tends to pi by 2 from the left hand side f of x is equal to limit x tends to pi by 2 from the right hand side of f of x. We get limit x tends to pi by 2 2x cot x plus b, which is equal to limit x tends to pi by 2 a cos 2x minus b sin x. Therefore we get b equal to minus a minus b. We get a plus of 2b equal to 0. Let this be equation 2. So by solving 1 and 2, we get a is equal to pi by 6 and b is equal to minus pi by 12, which is, we see our answer matches the option C. Therefore option C is the correct answer. The value of C in Rolle's theorem for f of x log x square a plus b plus ab upon x upon a plus b. In a comma 2, where a is greater than 0 is, I give 4 options over here. We have f of x is equal to log of x square plus ab upon x a plus b, which is equal to log of x square plus a into 2 minus log x a plus 2. Further, we differentiate, we get f of f dash x equal to 2x upon x square plus ab minus a plus b upon x to a plus b, which is equal to 2x upon x square plus ab minus 1 by x. We substitute the value x as c, we get c which is equal to 0, where we get 2c upon c square plus ab minus 1 by c, which is equal to 0. For the solving, we get 2c square minus c square minus ab upon c square minus plus ab equal to 0. Therefore we see c square minus ab we get equal to 0, that is c square equal to ab, which is c is equal to under root of ab, which is nothing but geometric mean of a and b. Therefore option B is the correct answer. Let f of x and g of x be differentiable for x greater than equal to 0, which is less than equal to 1, such that f of 0 is equal to 2, g of 0 is equal to 0, and f of 1 is 6. Let there exist a real number c in 0, 1, such that f of dash f of 3 is equal to 29. Then g of 1 is equal to, we have 4 options given. Let h of x is equal to f of x minus 2 g of x defined on 0, 1. F of x and g of x are differentiable for x greater than equal to 0 and less than equal to 1. Therefore h of x is differentiable on 0, 1 and continuous on 0, 1. Therefore h of 0 is equal to f of 0 minus 2g of 0 equal to 2 minus 0 equal to 2, and h of 1 equal to f of 1 minus 2g of 1 equal to 6 minus 2g of 1. Therefore differentiating, we get h of x equal to f dash of x and 2g of x. By Rolle's theorem on 0, 1 satisfies h, 0 equal to h of 1, which is equal to 2 equal to 6 minus 2g of 1. Further solving this, we get 2g of 1 equal to 4, which is g of 1 equal to 2, which is our answer matches option B. Therefore option B is the correct answer. Let's see MCQs on integration. Integral dx upon 7 plus 6x minus x square equal to, we get 4 options over here. We'll make a fine adjustment in the denominator, that we can write this integral as I equal to integral of dx. We take a minus out, x square minus 6x plus 9 minus 9 minus 7, so that we can write this as integral minus integral dx upon x minus 3 the whole square minus 4 the whole square. So we can write this as integral of dx 4 the whole square minus x minus 3 the whole square. Taking integral, we get 1 upon 2 and 4 log of 4 plus x minus 3, 4 minus x plus 3 mod plus c, which we get 1 by 8 log of mod 1 plus x upon 7 minus x plus c, which is, we see our answer matches the option B. Therefore option B is the correct answer. Integral cos cube x upon under root sin x dx is equal to, we give 4 options over here. We can write the denominator, that is I equal to cos x 1 minus sin square x upon under root sin x dx. We put t is equal to sin x, differentiating both the side we get dt is equal to cos x dx, which is I equal to integral 1 minus t square upon under root t dt, which is equal to integral t raised to minus half minus t raised to 3 by 2 dt. Integrating, we get 2 root t minus 2 upon 5 t raised to 5 by 2 plus c, which is equal to 2 root sin x minus 2 by 5 sin x raised to 5 by 2 plus c, which is, we see our answer matches with option D, that is 2 root sin x minus 5 by 2. Sorry, our answer matches with option B. Therefore option B is the correct answer. Let's see MCQs on definite integral. Integral minus pi by 4 to pi by 4 dx upon 1 plus sin x is equal to, we're given 4 options over here. We can write the integral part as, we can rationalize it, we get as 1 minus sin x upon 1 minus sin square x dx. Solving this further, we get minus pi by 4 to pi by 4 1 minus sin x upon cos square x dx, which is equal to minus pi by 4 to pi by 4 sec square x minus sec x tan x of dx. Further solving, we get tan x minus sec x minus pi by 4 to pi by 4. Substituting, we get tan pi by 4 minus sec pi by 4 minus of tan minus pi by 4 minus sec minus pi by 4, which is equal to 1 minus root of 2 minus of minus 1 root 2, which is equal to 1 minus root 2 plus 1 plus of root 2, which we get equal to as 2, which is, we see our answer matches the option B. Therefore option B is the correct answer. Integral minus 1 to 1 minus x square upon 1 plus x square dx is equal to, I give 4 options over here. We have integral of 1 minus 1, we can write this as 2 minus of 1, we make a fine adjustment in a numerator, x square upon 1 plus x square dx, where we can write this as 1 minus 1 to 1, 2 upon 1 plus x square minus 1 dx, which is equal to 2 into tan inverse x minus x minus 1 to 1, which is equal to 2 of tan inverse 1 minus 1 minus of 2 tan inverse minus 1 plus 1. Solving this further, we get 2 pi by 4 minus 1 plus 2 pi by 4 minus 1, which is equal to pi minus 2. Which is, we see our answer matches with option B. Therefore, option B is the correct answer. Let's see MCQs on application of definite integral. The area formed by triangular shape region bounded by the curve y is equal to sin x and y is equal to cos x and x is equal to 0 is, we're given 4 options over here. Since we have y is equal to sin x and y is equal to cos x, therefore sin x is equal to cos x, which is x is equal to pi by 4, and given x is equal to 0. So required area is equal to integral 0 to pi by 4 sin x minus cos x dx. Integrating, we get minus cos x minus sin x 0 to pi by 4. Further solving this, we have sin x plus of cos x 0 to pi by 4, which is, we substitute the value, we get sin pi by 4 plus cos pi by 4 minus sin 0 minus cos 0, which is equal to 1 upon under root 2 plus 1 upon under root 2 minus 0 minus 1, which is equal to root 2 minus 1. Which is, we see our answer matches with option D. Therefore, option D is the correct answer. If the area bounded by the curve y square is equal to 4ax and y is equal to mx is a square upon 3, then the value of m is, we are given 4 options over here. The area of the region bounded by y square equal to 4x and the y is equal to mx is (8a square upon 3m cube). Therefore, 8a square upon 3m cube is equal to a square upon 3. Therefore, we get m cube is equal to 8. Therefore, m is equal to 2, which is our answer matches with option C. Therefore, option C is the correct answer. Let's see MCQs on differential equation. E raised to x plus e raised to y is equal to c into e raised to x plus y. We have given 4 options over here. We differentiate both the side, we get e raised to x plus e raised to y dy by dx, which is equal to c into e raised to x plus y upon 1 plus dy by dx, which is, we give as equation 1. Sorry, let this be equation 1 and let this be equation number 2. Further solving, we get e raised to x plus e raised to y dy by dx is equal to e raised to x plus e raised to y 1 plus dy by dx. Further solving, we have e raised to x plus e raised to x dy by dx plus e raised to y plus e raised to y dy by dx. Therefore, we get e raised to y plus e raised to x dy by dx equal to 0, which is, we see our answer matches with option C. Therefore, option C is the correct answer. Family of lines making intercept A on the x-axis and B on y-axis. We are given 4 options. The equation of the family of line making intercept A on axis and B on y-axis is x upon A plus y upon B equal to 1. Let A is equal to 1 upon A and B equal to 1 upon B. Then the equation becomes AX plus BY equal to 1. Let this be equation 1. where we have a plus b dy by dx, where we differentiate with respect to x. Let this be equation 2. So we substitute the value, we get 0 plus, sorry, we differentiate again, we get d square by dx square equal to 0. Let this be equation 3. Therefore, further we get d square y by dx square equal to 0. Which is, our answer matches with option D. Option D is the correct answer. Let's see MCQs on probability distribution. A random variable x takes the value 0, 1, 2. Its mean is 1.2. Therefore, probability of x is equal to 0 is equal to 0.3. Then of x is equal to 1 is equal to. We have 4 options over here. Let the probability distribution of x is x p of x, that is 0, 1 and 2, 0.3 m and n. So summation of I equal to 0 to p of I equal to 1. Therefore we can write as 0.3 plus m plus n equal to 1. Therefore that is m plus n equal to 0.7, which is, that be equation number 1. So therefore mean is equal to summation of pi of xi equal to 0, 0.3 plus m plus 2n equal to 1.2. Therefore we can write as m plus 2n is equal to 1.2, which is our equation 2. By solving 1 and 2, n is equal to 0.5, we get m is equal to 0.7 minus 0.5, which is equal to 0.2. Therefore p of x is equal to 1, we get m is equal to 0.2, which is, we see our option C matches with our answer. Therefore option C is the correct answer. A random variable x takes values minus 1, 0, 1. Its mean is 0.6, and if x is equal to 0, probability of x is equal to 0 is equal to 0.2, then p of x is equal to 1 is equal to, they give 4 options over here. Let x and p of x minus 1, 0, 1, m, 0.2 and n. Summation of I equal to minus 1 to 1, probability of I 1 is equal to m plus 0.2 plus n plus 1 is equal to m plus n equal to 0.8. Therefore we have mu is equal to e of x equal to summation of I equal to minus 1, 1. Therefore xi pi equal to 0.6. Therefore that is minus m plus 0 plus n is equal to 0.6 minus m plus n we get as 0.6, which will be equation 2. Let this be equation 1. Therefore by 1 and 2 we get 2n is equal to 1.4, n is equal to 0.7. Therefore p of x is equal to 1 is equal to 0.7, which is, we see our answer matches with option A. Therefore option A is the correct answer. Let's see MCQs on binomial distribution. The standard deviation of q plus p the whole raised to 16 is 2. The mean of the distribution is, we give 4 options over here. So the standard deviation, that is sigma, equal to under root of npq is equal to 2. Therefore we get npq is equal to 4, where we have n is equal to 16. Therefore pq is equal to 1 by 4, but we have p plus q equal to 1. Therefore p equal to 1 upon 4p is equal to 1. Therefore we get p square, 4p square plus 1 is equal to 4p. That is 4p square minus 4p plus 1 equal to 0. Therefore we get this as 2p minus 1 the whole square equal to 0. Therefore 2p equal to 1, p equal to half. Therefore mean n into p, we get 16 by 2, which is equal to 8, which is our option B. Therefore, option B is the correct answer. For a binomial variate with n is equal to 6, if probability x is equal to 2, which is equal to 9, probability x is equal to 4, then the variance is, we give 4 options over here. Here, n is equal to 6 and probability x is equal to 2 is equal to 9 and probability x is equal to 4 is, we can solve this as 6 c of 2 p raised to 2 and q raised to 4, which is equal to 9 into 6 of 4 p raised to 4 and q raised to 2. Therefore, further solving, we get 15 p square q raised to 4 equal to 9 into 15 p raised to 4 q raised to square. Therefore, we get q square is equal to 9 of p square, which is q is equal to 3p. Let this be equation 1. So we know q is equal to 1 minus p. Therefore, let this be equation 2. So by 1 and 2, we get p is equal to 1 by 4 and q is equal to 3 by 4. So the variance, which is equal to npq, is equal to 6 into 1 by 4 into 3 by 4, which is equal to 9 by 8. Which is, we see our answer matches the option C. Therefore, option C is the correct answer. Let's see MCQs on circle. The equation of a tangent to the circle given by the equation x is equal to minus 2 plus 3 cos theta, y is equal to 3 plus 3 sin theta at p pi by 6 is, we're given 4 options over here. Given x is equal to minus 2 plus 3 cos theta and y is equal to 3 plus 3 sin theta, therefore we can write this as x plus 2 equal to 3 cos theta, y minus 3 equal to 3 sin theta. So we put x is equal to x plus 2, y is equal to y minus 3, therefore x square plus y square equal to 9 cos square theta plus sin square theta, which is we get as equal to 9. The equation of tangent at p theta is x cos theta plus y sin theta equal to 3. Therefore, x cos pi by 6 plus y sin pi by 6, which is equal to 3. We substitute the value, we get x of root 3 by 2 plus y of half equal to 3. Therefore, we get root 3 x plus y equal to 6. Further, we substitute the value of x and y, we get root 3x plus 2 plus y minus 3 equal to 6. For the solving, we get root 3x plus y plus 2 root 3 minus 9 equal to 0. Which is, we see our answer matches with option A. Therefore, option A is the correct answer. The normal at minus 1 comma 6 on the circle cuts the circle at the point 3 comma 2. Then the equation of the circle is, they give 4 options over here. Since the normal is passing through the center of the circle and it cuts the circle at 3 comma 2, therefore minus 1 comma 6 and 3 comma 2 are end point of the diameter. Therefore, x plus 1 into x minus 3 plus y minus 6 into y minus 2 equal to 0. For the solving, we get x square minus 2x minus 3 plus y square minus 8y plus 12 equal to 0. For the solving, we get x square plus y square minus 2x minus 8y plus 9 equal to 0. Which is, we see our option, our answer matches with option C. Therefore, option C is the correct answer. If the length of the tangent segment from the point P to the circle x square plus y square is minus 3x plus 4x minus 1 is equal to 0 and x square plus y square is equal to 8 are equal, then the locus of the point P is, we given 4 options over here. Let P x1 comma y1 be point on locus and PT and PT2 are the length of the tangent. Therefore, PT1 equal to PT2. For the solving, we have x1 square plus y1 square minus 3x1 plus 4y1 minus 1, which is equal to x1 square plus y1 square minus 8. Further, minus 3x1 plus 4y1 minus 1 is equal to minus 8. Further, we solve, we get 3x1 minus 4y1 minus 7 is equal to 0. The locus of p x1 comma y1, that is 3x minus 4y minus 7 equal to 0, is a straight line. Therefore, option A is the correct answer. Let's see MCQs on conics. This is parabola. The line Lx plus my plus n is equal to 0 will touch to the parabola y square is equal to 4x if, we're given 4 options over here. The line Lx plus my plus n is equal to 0, where we get y is equal to minus L upon mx plus minus n upon m. So this is minus, we get minus over here, minus L upon mx minus n by m. Slope m equal to m is equal to minus 1 by m, and c equal to minus n upon m. So we know that c is equal to a by m, therefore minus n by m is equal to a upon minus 1 by m. Since a is equal to small a, therefore nl is equal to am square. Therefore we see our answer matches option B. Therefore option B is the correct answer. The line y is equal to mx plus c touches the parabola x square is equal to 4ay if, we give 4 options over here. The line y is equal to mx plus c meets x square is equal to 4ay. Therefore, x square is equal to 4a mx plus c, which is equal to 4a mx plus 4ac, which we get x square minus 4a mx minus 4ac equal to 0. Here we get b is equal to minus 4am comma c is equal to minus 4ac, which we get a is equal to 1. Since discriminant is equal to 0, therefore p square minus 4ac is equal to 0. Therefore 16a square m square plus 16ac is equal to 0. So we get am square plus c equal to 0. Therefore we get c is equal to minus a m square, which is, we see our answer matches option C. Therefore option C is the correct answer. The slope of the tangent to the ellipse x square upon 7 plus y square upon 4 is equal to 1 from the point 3 comma minus 2 r. We give 4 options over here. Here a square is equal to 7. If we compare the standard equation of ellipse, we get a square is equal to 7 and b square is equal to 4. The tangent y is equal to mx plus under root 7m square plus 4 passing through 3 comma minus 2. Therefore minus 2 comma 3m plus under root 7m square plus 4. That is, we get minus 2 minus 3m is equal to 7m square plus 4. Squaring both the side, we get 4 plus 12m plus 9m square equal to 7m square plus 4, which is, that is 2m square plus 12m equal to 0, which we get as 2m m plus 6 equal to 0, which we get 2m is equal to 0, or m plus 6 equal to 0. M is equal to 0 or m is equal to minus 6. Therefore m1 is equal to 0 and m2 is equal to minus 6, which you see the answer matches option C. Therefore option C is the correct answer. The equation of the normal to the ellipse x square upon a square plus y square upon b square is equal to 1 at the end of the lattice rectum is, I give four options here. End of the point of lattice rectum L is equivalent to AE upon B square upon A. So normal at x1 comma y1 is x minus x1 upon A square, y minus y1 upon B square. Therefore normal at L is x minus AE upon A square equal to y minus B square upon A upon B square upon A upon B square. Therefore further solving, we get A x minus AE upon E is equal to AY minus B square. Further solving, we get AY minus A square bracket 1 minus E square x minus AE upon E, which is equal to y minus A 1 minus E square. Further solving, we get x minus AE is equal to EY minus AE plus of AE E raised to cube. Further solving, we get x minus EY minus of AE raised to cube, which is equal to 0. Which is, we see our answer matches with option A. Therefore option A is the correct answer. The condition that line Lx plus my plus n is equal to 0 touches the hyperbola b square x plus a square y is equal to a square b square is. I give four options over here. We know that the condition of tangency is c square equal to a square m square minus b square. Let this be equation 1. Therefore we have y is equal to minus Lx upon m minus n upon m, where m is equal to minus L upon m and c is equal to minus n upon m. From 1 we get minus n by m the whole square equal to a square minus L upon m the whole square minus b square. Therefore for the solving, thus we get n square equal to a square L square minus b square m square, which is, we see our answer matches with option A. Therefore option A is the correct answer. The line x cos alpha plus y sin alpha is equal to p touches the hyperbola x square upon a square minus y square upon b square is equal to 1. Then we give four options over here. We know the condition of tangency is c square is equal to a square m square minus b square, which is, let this be equation 1. So the line y equal to minus cos alpha upon sin alpha x plus p upon sin alpha, comparing with y is equal to mx plus c, we get m is equal to minus cos alpha upon sin alpha, c is equal to p upon sin alpha. So from 1 we get p square upon sin square alpha equal to a square cos square alpha upon sin square alpha, which is equal to, we further solve this, we get a square cos square alpha minus b square sin square alpha, which is equal to p square, which is, we see our answer matches with option A. Therefore option A is the correct answer. Let's see MCQs on application of definite integral. The volume of the solid generated by revolving the region bounded by the curve x square plus 3, then x-axis and the line x is equal to 1 and x is equal to 2. About the x-axis is, we give four options over here. We have volume is equal to pi that is a to b y square dx. Substituting, we get v is equal to pi 1 to 2 x square plus 3 the whole square dx. we have pi 1 to 2 x raised to 4 plus 6 into x raised to square plus 9 dx. Therefore, integrating we get pi x raised to 5 upon 5 plus 2x cubed plus 9x 1 to 2. Substituting the value we get pi 32 upon 5 plus 16 plus 18 minus 1 by 5 minus 2 minus 9. Further solving, we get pi 31 by 5 plus 23 is equal to 31 plus 115 upon 5 to pi, which is equal to, we get 146 pi upon 5, which is our answer matches option D. Therefore, option D is the correct answer. If the curve y is equal to tan x revolve about x-axis and the ordinates x is equal to 0 and x is equal to pi by 4, then the volume of the solid generated is, we give 4 options over here. V is equal to pi a to p y square dx. Substituting the value, we get pi 0 to pi by 4 tan square x dx. Therefore, further, pi 0 to pi by 4 sec square x minus 1 dx. For the solving, we get pi tan x minus x 0 to pi by 4. Substituting another, we get pi 1 minus pi by 4, which is equal to pi by 4 minus pi, which is, we see our answer matches option C. Therefore, option C is the correct answer.